Hello friends, welcome to my video. Today I am going to talk about record type in C# that was introduced in C# 9.0. We'll learn what record types are, how to declare and use it in a program. We'll also see how it is different from classes. Finally, we will talk about its benefit and best practices. Before we get started, just a quick reminder to subscribe my channel, hit the red button and don't forget to click on the little bell icon. That way you will be notified every time I upload a new video. Okay, without any further delay, let's get started. Record types in C# 9.0 onwards. What is record type? Record type is nothing but a reference type that has read-only properties by default. It is immutable by default, that means the value cannot change after it has been created. However, one can define the record type as mutable, but it would defeat the purpose of record. Okay, now let's see the syntax how to declare the record in C#. First, we need to write the public, then record keyword, then record name, opening and closing parentheses, and in between need to mention one or more parameter. That's why here I wrote public record, imply record, a string name and age. Here name and age are nothing but the parameters that imply record is going to accept. So this type of syntax is called record positional syntax. This one line of positional record syntax tells compiler to do multiple things. First, it instructs to create a public init only auto implemented properties for each positional parameter provided in the record declaration. Second, to create a primary constructor. Third, to create a deconstruct method with out parameter. So one line of positional record syntax is equivalent to the record shown over here, right? Where we have a primary constructor, then we are having a public init only auto implemented properties, and then a deconstruct method with out parameters, right? So if you notice over here, a string name which is of out parameter, again age is of int data type which is of out parameters over here. So basically one line of record syntax is equivalent to this much, right? Non-destructive mutation and records in C#. What is non-destructive mutation? Non-destructive mutation is a way for constructing a new object from an existing one without destroying the prior one. We can use non-destructive mutation for constructing a new record object from an existing one by using with keyword. We need to use with keyword whenever we are going to create new record object from the existing one via this non-destructive mutation process. Okay, let's try to understand with the help of examples over here. So there is a class program under the namespace demo. I have declared positional record imply record that has two parameters, name and age. Name is of a string data type, age is of int data type. Okay. Now in the main method, I have instantiated this object, the imply record, right? Where we have provided name as Akanksha and age is equal to 25. Then what I am doing in the next statement, I am just printing this object that was created in the previous statement, right? So I'm just writing console.writeline obj_r1 obj_r1. So basically this statement is going to print the object into this console window. Next, I am creating a new record object obj_r2 from the previous record object obj_r1 by non-destruction mutation process. In non-destruction mutation with keyword is used, and that's what, if you see the statement over here, I have written where obj_r2 is equal to obj_r1 with, and then I have just name is equal to Ravi I have assigned to it, right? So what I'm doing, I'm just creating a new record object obj_r2 by copying the obj_r1 record with different name as Ravi over here, right? And then in the next statement, I'm just printing the obj_r2 into the console window. And if you see the output shown below, obj_r1 is having name as Akanksha and age as 25, whereas obj_r2 is having name as Ravi and age is 25. So it simply depicts as new object obj_r2 got created where name property changed as Ravi and age is just copied from the previous record object as it is. Deconstruct method of a record. When a record is defined using positional record syntax, deconstruct method is generated by the compiler itself. Otherwise, we can create our own deconstruct method with out parameters. It allows us to use object deconstruction to access individual properties. Okay, let's try to understand with the help of examples shown over here. In program class, positional record is declared, right? That's what I have written, public record, imply record, a string name and age. Basically, there are two parameters, name and age, for this imply record. In this main method, I have instantiated this imply record, right? And I have given the name as objr1. And here I have provided parameter value Akanksha and age as Ravi, right? Now what I'm doing, I'm just printing objr1 into the console window. In the next statement, I have just written some dashed line, and then I just written this deconstruction of a record statement that is going to also get printed into this console window. Now I wrote where an a is equal to objr1. What I'm doing over here, we are destructing the properties into the local variable n and a over here. So that's what I am accessing the value n and a in the next statement, right? And that's what I have written console.writeLine record value of n is equal to n, value of a is equal to a. Now if you see the output shown over here, objr1 is having name as Akanksha and age is 25, right? That's what record value of n is equal to Akanksha and value of a is equal to 25 is getting depicted over here. So here we are on Visual Studio. Here we are going to see the demo of record type versus class. For that, I have created one console application named record in C# that has program.cs file. So there is a namespace named demo. Under that, I have declared positional record named imply record that accepts two input parameters, name and age. And there is a class declaration for imply class that has two auto implemented init properties, name and age. It also has parameterized constructor that accepts two input parameters, name and age. And this name and age is assigned to properties name and age. Okay. Now there is another class program that has main method, which is an entry point of this application. So here I have just going to print record type versus class demo in the console window as a first statement. Okay. Now I have created two instances of imply record objr1 and objr2 with the same parameters where name is Akanksha, age is 25. Similarly, I have created two instances of class imply class. For that, I have given the same parameters Akanksha and age. The object name is obc1 and objc2. Now what I am doing, I am just going to print the object for the record and object for the class. That's what I have written console.writeLine record object printing, and then I am just printing objr1. Similarly for class, object printing objc1. So this statement is going to print the object into this console window. Next, what I'm going to do at the next statement, I have applied JSON serialize method on record level and also at the class level. So for that purpose, I have written JSON serializer dot serialize, which is of imply record type, and then I have just passed this objr1 object over here. For the class, I'm just writing JSON serializer dot serialize, which is of imply class, and then I have just written this objc1 as a parameter I'm passing over here. So what it will do, it will just apply JSON serialize method, convert to object to the JSON object. Now here if you see, I have written record. I'm just going to do comparison between the objr1 and objr2. Objr1, what is that? It is that objr1 for this imply record object, and this is the imply record object also. But if you notice, objr1 and objr2 are having the same parameter value, Akanksha and age, which is nothing but the 25 over here. So in this statement, what I'm going to do is I'm just going to compare objr1 and objr2. Similarly for the class, I'm just comparing objc1 equal to objc2. So it will give true or false value, okay, for the record and class. Now in this statement, what I'm doing, I'm just going to use this equals method to verify whether this objr1 and objr2 are equal or not. For the class also, I'm just going to compare objc1 and objc2 whether they are equal or not. That's what I have written, equals objc1 objc2. So basically in this statement, what I'm going to do, I'm just going to do comparison at the reference level. That's what I have used, reference equals method over here. For this record, I have written reference equals objr1 comma objr2. For the class level, I'm just written reference equals objc1 and objc2. So whatever the output, true or false, that we are going to receive, that we are printing into this console writeLine statement, right? Now next, I have written get hash code for the objr1. Similarly for get hash code for objc1, we are going to get this hash code, and those hash code value that we are going to receive, I'm just going to print it for this obj r1 and obj r2. Similarly, I'm just printing the hash code for obj c1 and obj c2. Okay, so this statement is doing for getting this hash code for r1 and r2, c1 and c2, and printing into this console window. Right now, in the next statement, I am just going to explore the feature of the records. Right, so first feature, deconstruction of record for accessing individual properties. So for that, what I have written this statement where n comma a is equal to obj r1. So basically we are assigning obj r1 attribute values to these local variables, right? And then we are going to print this value of n and value of a over here. And in next statement I have written record value of n is equal to n and value of a is equal to a over here. Now in the next statement I am just going to see the record non-destructive mutation demo. What I'm going to do over here, I'm going to create a new object obj r3 with the help of obj r2, and I'm changing the name attribute value over here, right? And then whatever the obj r3 is going to get created, I'm just printing into this console window. That's what I have written, new record created by non-destructive mutation obj r3. Right now here I'm just going to see the demo of the inheritance in record. Right, so for that, what I have written, we have already this record, right? Positional record, imply record, right? That accepts two input parameters, name and age. And if you notice in this statement, I have inheriting this imply record. So in this statement, what I'm doing, I have defined this record financial imply record that accepts three input parameters, name, age and country. And then I am inheriting this imply record where we do have name and age already over there. So this is the way how we are going to write inheritance for the record, right? Now in this statement, in inheritance and records, I have created one instances of this financial imply record, and I have given this name Daniel, age 30 and country as Romania. And whatever the object got created, I am just printing into this console window, right? Let me execute this program and see the output. Okay, so output got appear into this console window. If you see here, the first statement got printed record type versus class demo. That was intended to print it because I'm just giving the demo of record type versus class, right? And that's what it got printed over there. Now, if you see the record and class, for the object printing, it is printing imply record name is equal to Akanksha and age is equal to 25. And it is very neat and clean that depicts what are the attribute name and what are the attribute values. But if you see the class for the object printing, it just says demo.imply class. So basically it is just giving this namespace dot class name. That's it if we are going to print the object for the class. So if you see the record, it's a neat and clean, and we come to know, okay, what is the class name, what is the attributes, what are the attributes that this record is having, and what is the values associated with that, right? So those things is very much clear. So if we do have such type of requirement where this logging is required, right? So we just print the object, it will be coming with the value and the name, value and properties name all together, right? So it's a very neat and clean to print like this. It will make sense, right? Now if you see the second statement, where we have applied the JSON serialize method, and then record object got printed like this, name Akanksha is equal to 25, and the similar JSON serialize method applied on the class object, and then it got printed name is equal to Akanksha, age is equal to 25. If you see, both are equivalent, right? Now we are comparing obj r1 is equal to obj r2, right? So obj r1 and obj to r2 are having the same parameter values, and that's what it is just giving as a true, because it's the value type equality is happening for the record. If you see this class, so obj c1 and obj c2, even though they are having the same value, but location is different. That's what it is coming value as a false. Now equals method that applied for the record level obj r1 and obj r2, and it is saying the same thing as a true, what it depicted for the equal to operator, right? And for the equals for the class, it is giving us the value as a false. Now if you see the reference equals obj r1 and obj r2, then it is giving the false value, and for the class also it is giving the false value. The reference equal, it is happening at the reference level. And obj r1 and obj r2 is having the two different objects, right? That's what it is giving the value as a false over here. And class also, obj c1 and obj c2 are the both two different objects, and we are comparing on the reference level, and that's what it is coming as a false value. Now if you see the get hash code method that we applied on the record level of obj r1, it is giving the value of this one 16549588008. And if you see this obj r2 the get hash code, it is having the same value. Why it is having the same value? Because get hash code of obj r1 and get hash code of obj r2 is having the parameters values same, and also equality is happening. But if you see for the class, it is having the different value. This one is different and this one is different, right? Okay, now if you see the feature of records, where we have deconstruction of record for accessing individual properties, where we have the deconstruction of record, and then we have assigned the properties values of the local variables, and then we are printing what is the value of n, then that is the Akanksha got printed. What is the value of a, then 25 value got printed over here, right? Now if you see this record non-destructive mutation demo, here we have created new record, and this record got printed where we have name is equal to Rabi and age is equal to 25. Now if you see the inheritance in records, we have created obj fr1, which is nothing but the financial employee record. And if you see, it was inheriting employee record, and then we have printed this name Daniel, age 30 and country is equal to Romania. Record type versus class. Here we are going to see the difference between record type and class. That's what I have written, record type versus class. So in record type, number one, record type is a reference type that has read-only properties by default. Its fundamental use is storing data. Whereas class is also a reference type that can have read-only properties if needed. Its fundamental use is defining responsibilities. Number two, record type is available in C# 9.0 onwards. Whereas class, it already exists before C# 9.0. Number 3. Record type is immutable by default. What does it mean? It means record help us to ensure that we don't accidentally change or corrupt data due to its immutable nature. Basically, it guarantees us that whenever we are going to pass record type to some method or somewhere, it is not going to get changed accidentally, or someone wants to also change, it is not going to get changed. That's why record type is immutable by default. However, one can define the record type as mutable, but it would defeat the purpose of record. Whereas classes are mutable, so even if they have the same data, doesn't mean they are having the same data, because its value can be changed later. Number 4. After instantiation of record should not have any state changes, whereas classes changes the properties values. Number 5. If there is a need to change the state in record, we could create a new records from the existing one. With classes, we modify the existing one. Number 6. Use a record when an object's only purpose is to contain public data, whereas we use a class if class object has unique logic. Number 7. Record can be sealed or abstract. Class can also be sealed and abstract. Benefits and best practices. So here we are going to discuss about the benefits and best practices associated with a record. Benefits. Number 1. It provides an easy and concise syntax. Number 2. Being an immutable, it is a thread safe. Number 3. It provides inbuilt support of constructor deconstruct for positional records. Best practices. So here we are going to see when to use records and when not to use records. When to use records. Number 1. Value-based equality and comparison of objects. So whenever their value-based equality and comparison of the objects are required, then we can use records. Number 2. When we want to ensure the property values on an object cannot be changed during the execution of other processes. In that case also we can use record. Number 3. It can be used while loading or retrieving data from a database or doing some pre or post processing of the data before it is committed or dispatched to your domain layer. So whenever we are going to deal with the data, whether it's a case of loading the data or retrieving the data, or we are doing some sort of pre and post processing of the data before it is committed or dispatched domain layer, in that case we can use records. holding data from external services that does not change. In that case also we can use records. When not to use records, number one, when there is a need to change the data. So there is a requirement where the data changes can happen. So in that case, we should not use records. Number two, when object has own unique logic. Number three, do not use records in the API control. So basically, these are the benefits and best practices are associated with the records in C#. Now that brings me to end of my session. To sum up, in this video, we saw what record types in C# are and how we can define and access it in a program. Then we talked about non-destructive mutation, what it is and how we can use it for records. After that, we saw how deconstruct method of a record help us to access individual properties. Then we talked about how record is different from class. Finally, we discussed some benefits and best practices associated with it. That's all for this video, guys. If you like this video, hit the like button, share it with your friends and colleagues, subscribe to my channel if you haven't done already. Thanks for watching. See you next video.